So we have drawn the op-amp circuit in the previous video. You can go to cell, generate symbol, and then you can create a symbol by clicking on replace. I have already created one. Now we'll go to cell. You have to go to new view, and then you give the name. Let us say op underscore t. Say OK. Now here you press on I. The symbol of the op amp, you place it here. You can see that the op amp has got V bias in one into VSSA and VDD and V out. Now we go to V source, spice source. Next we'll click on VDC. Now we require VDC at 3 points. One is for VDD-A. Next is for bias. So for biasing V bias, I'll just rotate it. Next we'll connect between into and the ground. Next we'll select on VAC. And we need to place it between in 1 and in 2. So I'll just move this down. We'll make the connections. The other end of this potential, I'll mark it as VSSA. From in1 to AC voltage, AC voltage to in2, and AC to DC voltage. And here I label as VSSA. The other end we'll label it as VDDA. I want to give this voltage as 2.5 volts. So you can directly give 2.5 volts here, or a new method I'll be using. I'll just give a label here like V power, V PWR. Then this DC voltage will be labeled as V power. Next, this voltage I'll label it as VCM. So if V power I want to take it as 2.5 volts, then VCM is 2.5 by 2, that is 1.25 volts. AC voltage magnitude 1, phase 0, VDC 0. So I don't want to make any changes. And V bias voltage will give 700 millivolts. We'll use the wire to label this point as VDDA. Similarly, I'll use the wire for VSSA. I'll label this as VSSA. Now at the output side, I'll label this as V out. And I want to add a capacitor at this point, so I'll press I for instance. Capacitance is available in devices library. And place the capacitance here. Now the capacitance value we need to change it to 200 femto 200 femtofarads. So we'll change the capacitance to 200 femtofarads. The other end will connect it to ground. I'll just label it as VSSA. Now VDDA we have connected the power supply here, but VSSA we have not connected any power supply. So what we do is that actually this VDC I can connect directly to this particular point. I have made the connection here. So to VSSA I can make the connection here. You take a DC voltage, so I'll press I. Change the library to spice source. So here we'll select VDC. I'll make this as 0 volts. I'll take a global ground. So global ground is available in miscellaneous. Global ground. I'll place that here. Press escape. Now use the wire. We'll make the connection. And then we need to add the output measurements, whatever we want to measure, or we need to print the magnitude of the AC voltage in decimals and the phase of the AC voltage in degrees, so that we need to add here. So I'll press I. First we'll go for spice plot. VAC decibel magnitude print. Then VAC phase print. Next we'll go to spice measure. In spice measure you can add all these things. I'll just add AC gain, measure AC gain, AC phase margin, AC unity gain frequency. You can actually add AC 3 dB frequency at maximum gain, gain bandwidth product if you want to know the values of these things. But I am going to add only these. Now use a wire to make the connection between them, so that because all these things have to be connected to the output. I can either use a wire to make the connection to the output, or I can just label this wire as V out, indicating that these two are connected together. The output V out and this both are connected together. Now we will check for any corrections in the circuit, any mistake errors are there. So I'll just save the circuit, press on tick mark. There are 0 errors and 0 warnings found. So let us proceed. Go to the setup of the simulation. Go to general. We need to browse the library files. In ECE folder, you have Tanner EDA, Tanner tools, process, generic 250, models, generic 250.lib. But here some dots are there, so we need to fill those things. So right click on .lib, properties, and copy home and ECE. Paste it here. At the end, space and TT. Space and TT. So general part is over. Next we had put PV power and VCM. Now this is the new way in which I can actually assign the values. Otherwise directly the values can be placed in the component itself. Now for assigning the values, we go to parameters and click this particular symbol. V power is the name of the parameter, and the value I need to give it to is 2.5 volts, and say OK. So that will be added here. One more I want, so that is VCM, and the value is V power by 2. I need not calculate, I just write V power by 2. So automatically it will take VCM as 1.25 volts. Now AC analysis, put a tick mark here. Sweep type is logarithm decade. Start frequency is 1. Stop frequency is 100 mega. So you have to type MEG. Number of frequencies is 10. Say OK and let us run the simulation. So we have got ME1, ME2, ME3 values here in after the simulation. And the first graph shows the AC voltage magnitude in decibels, and second graph shows the phase of the AC voltage in degrees. Now in the simulation status, these are the values which we have got for the measurements we have placed in the schematic. ME1 was is maximum gain. So maximum gain we got it as 44.1811. ME2 was phase margin, and phase margin we got it as 49.946962. Next, unity gain frequency. Unity gain frequency is equal to unity gain bandwidth, which is equal to frequency at which the gain is 0 decibels. So this value we got it as 11.8319 mega. What is the phase margin? Phase margin is the value of the phase from from the point. I'll just show you how to compute phase margin and gain margin from the graphs. Now what you need to do is see in the magnitude graph, 0 decibels point where it intersects the graph, will place a cursor. So a vertical cursor we need to place. So 0 decibel, and here we'll get an approximate value. So I'm just placing it here. One cursor. So 0 decibels magnitude and the graph cutting at this particular point. Next, one more vertical line cursor I'm going to place when 0 decibels and the graph are going to cut. 0 decibels and the graph are going to cut. I actually zoomed it. Second. Zero decibel cuts at this particular point. Sorry, 0 degrees. So we'll place a cursor here. So this is the cursor where 0 decibels magnitude and the graph are going to cut. We project and you get the phase margin. and here it cuts a 0 decibel, so this part gives us the gain margin.